Hello, good evening, everyone. Today we will go ahead and take another question of the past year paper. Beta, last time in yesterday's class, we had taken question number 7. है ना जी? एक बारी please last video को देख लेना. We have already covered this question thoroughly. This question was about beta monopoly versus perfect competition. In today's class, beta, we will talk about game theory. We'll take this question. This is 7B. बहुत ही इंटरेस्टिंग क्वेश्चन है. एक बारी देखते हैं कैसे सॉल्व होगा. There are n people sitting in a room. Each one is asked to guess an integer between 1 to 100. बहुत ध्यान से समझना है क्वेश्चन बेटा. Very, very interesting and important question. Each one is asked to guess an integer between 1 and 100 and write confidentially on the paper. The average of all number written on the paper is taken, and person whose guess is closest to 2/3 of the average is or are the winners. Find the Nash equilibrium action profile of this game. How will the answer change? If winner will be the players whose guess is closest to 2 times the mean of the guesses. Okay. Let's think about this question. Question 7B. So when we talk about n players, each of these n players beta have to go ahead and they're sitting in a room and they're asked to guess an integer, right? These n players, they're asked to guess an integer between 1 to 100. Okay. So we can just write down beta. So they have to guess an integer between 1 to 100. Now, sometimes it is also optimal that you go ahead and you take maybe n as some number. अगर आप n को कुछ number लेके करोगे, that is also going to go ahead and help you solve the question. अगर supposedly I take n as 40 or I take n as 50, that is also going to help me to understand the question better कि ये question कैसे solve होगा. Otherwise, even if you take n as a general number, that is also fine. So it is both way is fine. Okay. Now just take an example. So let's say that each of the individual, बहुत ध्यान से समझो बेटा, guesses the number as 1. Each of the n players. अब n की मैंने कोई value नहीं ली है, so I'm just writing like this: 1, 1, 1, 1 till 1. Each of the individual guesses the number as 1. My claim is that this is a Nash equilibrium. My claim is that this is a Nash equilibrium. Why? This says, and write it confidentially on the paper, the average of all number written on the paper is taken, and person whose guess is closest to 2/3 of the average is the winner. So if I take the average of all these ones, beta, what will be average? Average will be 1 plus 1 plus 1. 1 is coming n times divided by the number of individuals, n. So it will be n by n. So its average will also be 1. Right? Average will also be 1. Are you getting it? Now it says the average. Now it has to be 2/3 of this, right? It has to be 2/3 of this number. This is what it says. So it says the person whose guess is closest to 2/3 of the average. So 2/3 of the average kitna ho gaya beta? 2/3 of the average ho gaya 2 by 3, which is 0.67. Each of this individual, when they guess 1, 1, 1, 1, 1, each of them is close to 0.67. Every one is close to 0.67. They are closest to 2/3 of the average, isn't it? Right? So which means that each of this individual automatically becomes the winner of this game. They will go ahead and win this game. And because they will go ahead and win this game, there will be no incentive to deviate from this strategy. अच्छा, इसका deviation क्या हो सकता है अगर मैं कुछ भी सोचूं? Let me just think about it. So let's say that one of the individual decides to deviate. And everybody is guessing 1, but one individual guesses 0. ठीक है बेटा? One individual guesses 0. So beta, what will be the average? The average will be 1 plus 1 plus 1 plus एक 0 आ जाएगा, divided by the number of individuals n. So beta, 1 is going to come n minus 1 times. Plus 0 upon n. So this will be beta n by n minus 1 by n. This will be 1 minus 1 and very, very close to 1. Suppose assume karo ki 100 log hai. So suppose n is 100. Suppose I just give you an example. So beta 1 minus 1 by 100 is just very, very close to 1 only. Na? So it will be just 1 minus 0.01. Hai ki nahi hai? This will be 0.99. It has to be close to 1. So kyunki the average is close to 1. Right? Because the average is close to 1, even when I find it's 2/3, beta. Even when I find it's 2/3, this will be 0.66. So these individuals, beta, jinka 0.66 se close hai, they will win. And ye jo jisne 0 guess kiya, the individual who guessed 0, he is very away from 0.66. His gap from 0.66 is 0.66. ये और इसका गैप 0.66 का है, but इसका और इसका गैप 0.33 का है. Are you getting it? So beta, this person will lose the game. So when so how do we show that something is a Nash equilibrium? We show something is Nash when no individual has an incentive to deviate. And in this case, we are showing that this is Nash by showing that no individual here has an incentive to deviate. Are you getting? Right? So I have just taken one example of showing why this should be a Nash. ठीक है जी. अच्छा, next. Let's look at the second part now. It says, how will your answer change if the winner will be the player whose guess is closest to 2 times the mean of the guesses? 2 times the mean of the guesses. तो बेटा एक एग्जाम्पल ले लेते हैं इसका भी. second part. Let's say that the strategies are this 100, 100, 100. Let's say that the strategies are 100, 100, 100 till 100. I want to go ahead and बेटा थोड़ा दिमाग लगता है ये Nash equilibrium के जितने questions हैं, these are not going to be straightforward in the exam. They will be difficult questions in the exam. The microeconomics part is the most difficult part in exam and in entrance exam also. Okay, and one thing that I want to highlight here, beta, is that even during our time when we used to give the exam, there were maximum, I'm not saying it in the wrong sense, but there were maximum ERs, maximum back in the microeconomics paper. You have to do it very thoroughly. It's a difficult paper. Okay. So beta, let's say that the strategy is 100, 100, 100 till 100. So what will be the mean? The mean will be 100 is coming n times. Mean will be 100. Right? Now it says it has to be close to 2 times the mean value. So 2 times the mean. That means 200. 200 is 2 times the mean. So as long as each of the individual is giving the same value, they're giving the same answer, we are going ahead and we are getting, this is what it says. If the winner will be the player whose guess is closest to 2 times the mean. But if they're giving the same answer, then each of them is equally close to the 2 times the mean. So then each will be winner. है कि नहीं है बेटा? फिर एक incentive to deviate दिखा दो. So let's say that one of the individual deviates. So it will be 100, 100, 100, and one of them will be 99. So beta, when we find the mean, it will be 100 plus 100 and so on, plus 99 by there are n players. So 100 will be coming n minus 1 times and plus 99 upon. This will be your mean value. बेटा इसको solve करने के लिए अगर n की कोई value ले लोगे, it would be easier for you to solve. Otherwise, it may become a little difficult. अगर 100 की, if you take n as some value, let's say that there are 100 players in the game. So I know that this will be 100 into 99 plus 99 upon 100. So I know this will be 99 plus 0.99. So beta ये हो जाएगा 99.99. So even if you take 2 times the mean value, it will be 99.99 into 2 beta. This is very close to, much more closer to these 100 values rather than 99. So this person will lose and these will win. So because this will lose, he has no incentive to deviate. Why will he deviate from 100 if he is losing the game? So just take one example each. Beta, this is 2 marks each. Take one example each where you can show that there is no incentive to deviate, and that is it. Okay, so this completes the 7th question completely. Beta, सबसे पहले हम लोगों ने ये वाला part किया था 7A, and now I have done 7B also. Okay, now let's go to another question. So let's take question number 3. Okay, this is what you're requesting. Let's take question number 3. Okay, an individual's inverse demand function for the commodity is given by Px is equal to 10 minus Qx. ठीक है, तो बेटा थोड़ा सा समझ लेते हैं. The demand function, this is given by 10 minus Qx, where per unit market price Px captures his marginal willingness to pay for the commodity X. There are 10 individuals with same demand curve. So N is given to me as 10. I have 10 individuals who have the same demand curve. Okay. Now it says Find and plot the market demand curve for X if X is a private good. Okay. So beta, we know that for private good, we always do horizontal summation. What is the meaning of horizontal summation, beta? Horizontal summation is you take price as given and you add the quantity of different individuals. So you add quantity of different individuals. So what will happen? I have a demand function of individual A. I have a demand function of individual B, of individual C, and so on. At a given price, I will find demand of A, I will find demand of B, I will find demand of C, and I will add all these demand together. This is called horizontal summation. ये हमें यहाँ पे करना है. So beta, Px is given as 10 minus Qx. So what will be demand of individual A? 10 minus price. है ना? इससे Qx निकाल लिया. ये हो गया 10 minus Px. Now there are these individuals are similar. So individual A की demand हो जाएगी 10 minus Px. ऐसे ही individual B has the similar demand 10 minus Px and so on. Till whatever 10th individual I have, he also has 10 minus Px. But I told you, you have to do a horizontal summation of the prices. सारे prices को horizontally sum up करना है. Of the quantities, sorry. So we know that quantity of A plus quantity of B till the 10th individual, there are 10 individuals, will be 10 minus Px plus 10 minus Px and so on till 10 minus Px. तो बेटा ये हो जाएगा 100 minus 10 Px और ये हो जाएगी market demand. This is your first answer. The demand in the market is adding individual demands together. So I start with demand of individual A plus B plus C plus D. ऐसे करके you keep adding individual demands together and you get the demand of the private good in the market. Let's go to the second part. This says, find and plot the market demand curve for X if X is a public good. But a public good में reverse हो जाता है. So if we come to the second part, in case of public good, there is vertical summation. So what will happen? You will fix the quantity and you will check what is the willingness to pay by different individuals. So, you know, I am saying, look, I want to produce this much units in the market. Individual A might be willing to pay PA. Individual B might be willing to pay PB. C might be willing to pay PC. So what is the price paid by different individuals in the market? That is called vertical summation, right? So beta, usko reverse kar dete hain. Px is given as 10 minus Qx, right? I am fixing Qx now. And I am saying, look, PA, what price individual A pays is 10 minus Qx. What price individual B will pay will also be 10 minus Qx only because they have similar demand function. And what price the last individual will pay, 10th individual will also be 10 minus Qx. So beta, the price that I receive totally, PA, willingness to pay by A plus B till 10th individual, this is going to be 10 minus Qx plus 10 minus qx and so on. So this is going to be 100 minus 10 qx. And this is the price paid by all individuals as a whole. This is q. So when I find out what is the price paid by all individuals as a whole, this is called vertical summation. In vertical summation, you add prices that each individual is willing to pay for one quantity. एक ही given quantity है. I just want to produce one park, one flyover and so on. But here you will go ahead and add horizontal. यही difference है बस. अच्छा, next part it says, if marginal cost of providing good X is 10, find efficient quantity of the public good provided. तो बहुत simple है. Marginal cost 10 rupees है. मतलब जितना भी इंडिविजुअल ए पे कर दे, बी पे कर दे, सी पे कर दे, whatever A pays, B pays, C pays, and so on, the good will only be provided if totally they are able to pay the cost of the good. अगर मेरे को कोई फ्लाईओवर की कॉस्ट ही नहीं पे कर रहा, how will I make the good? So ultimately good, public good will be produced only if the cost is covered. तो ये जो 10 लोग थे, these 10 people together, they have the price that totally they're paying beta is this much. So if this is able to cover my marginal cost of producing the good, then the good will be produced in the market, and then you can go ahead and tell how many will be the efficient units in the market. तो इसको बस 10 से equate कर दो, marginal cost is 10. So 100 minus 10 qx is 10. 90 is 10 qx. Qx is 9. This is the amount efficiently produced in the market. State the condition for Pareto efficient allocation of two private goods, A and B, okay, and one public and one private good. Okay. Let's look at the third part now. So beta, when there are two, अच्छा इसकी explanation खुद से लिख लेना. I'm just writing it in short. So when there are two public goods, two private goods, that's the part that it's asking. So what does each individual does? Each individual will equate. क्या करता है हर इंडिविजुअल? अपनी बजट लाइन को ही तो इंडिफरेंस कर्व से टेंजेंट करता है, राइट? सो ईच इंडिविजुअल विल इक्वेट एमआरएस टू द प्राइस रेशियो. एमआरएस टू द प्राइस रेशियो. बट बिकॉज दे फेस द सेम प्राइस इन द मार्केट, मार्केट में प्राइस तो सेम ही है, सो देयरफॉर इक्विलिब्रियम जो बेटा आ जाएगा वो आ जाएगा वेयर एमआरएस are equal for the two individuals. This is your equilibrium condition. This is your equilibrium condition for two private goods. ठीक है. Second part says public and private good. So one public and one private good. बेटा जब एक पब्लिक और एक प्राइवेट गुड होता है तो उसकी कंडीशन ये रहती है दैट व्हाटएवर each individual is willing to pay for the good, when that is summed up together, it should be able to cover the cost of the good. So बेटा इसको हम ऐसे लिखते हैं, summation MRS. I am trying to go ahead and I am trying to find how I want to substitute one good for another. कौन से गुड है? एक पब्लिक गुड है G और एक प्राइवेट गुड है I, या प्राइवेट गुड को किसी और से रिप्रेजेंट कर लो X. इन दोनों के बीच में the rate at which I want to substitute, I want to add that rate for all individuals in the market. तो हर इंडिविजुअल का, for every individual from I to N, I want to add the rate of substituting one good for another, public good for private good. And when I add that together, it should be equal to the cost of providing the public good. It should be equal to marginal cost. If this condition is satisfied, then you go ahead and you achieve the Pareto efficiency condition. I'm not taking this in detail because of the time constraint, but this is what the condition is. So ye do condition, if you list them down, you will get marks for this question. Okay, beta, let's go to the next question. Iska next part dekhte hain. So in a market, two type of sleeping mattresses are sold, those of high quality and those of low quality. Buyers with limited information on quality are unable to identify one type from another, okay, unless they have purchased one and used it for some other type. If quality was perfectly identifiable and buyers would be willing to pay 25,000 for H type and 18,000 for L, in the presence of asymmetric information, buyers are willing to pay average price, okay. You can also provide warranty for which the cost is this and this, okay. Warranty does not enhance quality, of course. Will offering a warranty serve as effective signal for separating equilibrium in the market for mattress? Okay, beta. It's a very good question. You can only solve this question if you are very thorough with the conditions of imperfect information. Agar ye conditions nahi आएंगी, then you cannot do anything related to these kind of questions. So you have to be very thorough with the conditions. अच्छा बेटा एक चीज और है जो I just identified, and as far as I remember, when last year I was in Delhi University, this was also when I was teaching as part of Delhi University, this was also highlighted to us. Beta, if you see the English question, it says 18,000. But sometimes क्या होता है ना, गलती से हम हिंदी का नंबर पढ़ लेते हैं, and if you see the Hindi number, it says 8,000, right? So one says 18 and one says 8. Now, whether you have solved it with respect to 18 or 8, both are correct. दोनों में ही marks were provided. So whether you solved it with respect to 18 or 8, both answers are assumed to be correct. Okay. Now, beta, let's go to the first part. अच्छा, एक और mistake था यहाँ पे. This is not 77. This is a sign. Okay. Okay. Let's go to the first part now. Okay. So in this case, beta, we need to go ahead and we need to understand when will warranty be provided. Will it be an effective signal or not? So iski better condition likh lo, please. So the condition for this is the following. So you're given that price of high is 25,000. Price of low is 18,000. You're given that signal cost is for high is 5,000. 5,000 में warranty का sign दे सकते हो. And signaling cost for low is 9,000. ठीक है जी. अच्छा, now just take the first part. When I talk about effective signal, a signal is said to be effective if the following conditions are satisfied. A, pH minus PL, बहुत simple condition है, but ये याद होनी चाहिए, is greater than CH, and B, pH minus PL is less than CL. ये दोनों ही condition अगर satisfy होंगी, then it is an effective signal. Otherwise, it is not an effective signal. So both the conditions have to be satisfied. अच्छा बेटा, conditions एक बारी हम देख लेते हैं whether these conditions are satisfied or not. So if I look at the first part, pH minus PL, ये हो गया हमारा 25,000 minus 18,000, and the gap between the two is 7,000, which is beta clearly greater than CH, 5,000. So this condition is satisfied. Look at the other condition, beta. pH minus PL. This is 7,000 and this is clearly less than 9,000 जो cost of providing warranty for L है, so this is also satisfied. So beta, because both the conditions are satisfied, it is a clear effective signal, and that's your first question. That is what it is asking you. It is saying, will offering a warranty serve as an effective signal? The answer to this question is yes, it will. And we just wrote down the conditions for it. When will it be an effective signal? Is this clear? Okay, beta, go to the next part. Is if the proportion of H-type matrix in the market is some theta, delta, whatever you want to take, what is the value of this in achieving a pooling equilibrium? तो ये बेटा बोल रहा है कि कुछ हाई मेट्रिक्स हैं, कुछ लो मेट्रिक्स हैं, इसकी क्या वैल्यू ली जाए कि एक पूलिंग इक्विलिब्रियम पॉसिबल हो पाए, राइट? सो प्लीज राइट डाउन. Let's write down the second part of the question. Because this needs a lot of practice now. Right. So for pooling equilibrium तब worthwhile होता है, एक बारी समझ लो. It is then you find out a pooling equilibrium जब high type consumer जो है, जो high type seller है, वो अपनी वारंटी ऑफर ना करना चाहे. So please write down, for pooling equilibrium it must not be worthwhile. It must not be worthwhile for H-type seller to offer warranty. So pooling equilibrium सिर्फ तब चलता है जब जो हमारा हाई टाइप सेलर है वो वारंटी ऑफर ना करना चाहे. He does not want to offer the warranty. So बेटा the condition for this is, अभी याद है हमने PH minus PL की एक कंडीशन लिखी थी इफेक्टिव सिग्नल के लिए. तो for this we want that जो भी हमारा नेट अमाउंट बच रहा है, the price of the matrix minus the cost that I'm incurring for warranty, it should be less than the pooling amount. और pooling amount कैसे निकलेगा? जो भी amount, so these many high type sellers are there into price of high type seller plus these many low type sellers are there into price of low type seller. So if pool करके मतलब कि जब हाई और लो मिल रहे हैं, the weighted average जो अमाउंट उनको प्राइस मिल रहा है, if that is more than वो अमाउंट जो वारंटी देकर मिलता. थोड़ा समझो, PH मेरे को अपना मेट्रिक्स सेल करके मिल रहा है. आई एम गेटिंग दिस अमाउंट व्हेन आई सेल द मेट्रिक्स. इस पे मेरे को ये वारंटी देनी पड़ रही है, तो जो मेरा नेट अमाउंट है वो इतना पड़ रहा है. अगर मैं वारंटी देती हूं, इफ आई गिव वारंटी ऑन माय मैट्रिक्स, the net amount I will get from my matrix is this much. और अगर मैं वारंटी ना दूं और अगर मैं पूल करूं, if I go for an average amount जो भी मार्केट में चल रहा है उस एवरेज पे अपनी मेट्रिक्स को बेच दूं, I will get this amount. तो बेटा अगर ये एवरेज अमाउंट ग्रेटर है than the amount I get after providing warranty, तो मैं there is no reason now why I will go for the warranty. I will go for pooling. Isn't it? I will go for pooling. So the answer to this is, just solve this, bacha. So you just go ahead and say that PH is 25,000. Cost of providing warranty is 5,000. तो जो मेरी left hand side है, that is 20,000. This has to be less than PH is 25,000 plus 1 minus this. PL is 18,000. No? So if I solve this, I will get 25 minus 18, 7,000 this and plus 18,000. ठीक है, तो ये हो गया 2,000. Just solve this beta. 2,000. अरे यार, less than 7,000 this. So if this this amount is greater than 2/7, मतलब अगर जो मेरे high sellers हैं, high quality sellers, if their ratio is more than 2/7, if they are more in number than 2/7, then they will go for pooling equilibrium and they will not go for selling it separately by showing warranty. ठीक है? Is this making sense? So this is a good question. ये answer, ये amount तब है when I sell on my own. I don't want to pool with the low quality sellers. ये amount तब है when I pool with the low quality seller कि अच्छा ठीक है, इतने लोग high quality seller है, हर एक का प्राइस इतना है, इतने low quality seller है, हर एक का प्राइस इतना है, तो ये weighted amount हो गया. If this weighted amount is more than what I get individually by showing warranty, there is no reason I will go for warranty. So agar this amount is greater than 2/7, you will not show warranty. That's the answer to your question. So that is how you will go ahead and solve question number 3. I hope you are clear with these, beta. Now, most of the questions we have gone ahead and solved. Best of luck for your exam tomorrow. I am hoping that, just let me know how was your exam tomorrow. And I'm hoping that all of you will do very well. Thank you.